Hello students, today we learn about the nebula and the formation of solar system, the interesting phenomena, the formation of earth and other things, black hole or the sun, the interesting things uh, like that today we'll learn. So let's start. Okay. First thing you know what is nebula. So, nebula is a cloud of gases and dust particles. Gases like hydrogen, helium, and is mainly hydrogen, helium, and like cluster particles, dust particles are here. Mainly the gases are ionized. Hydrogen is ionized. Okay. So what is the evidence of nebula? Is nebula occurs? Is there any nebula? We see in the sky. If we peep in the sky, we see uh, many stars. If we see in the sky, we see many stars. The star and nebula. Stars mainly form from nebula, and nebula is nothing but the interstellar clouds of gases. Okay, so we see in this if we use telescopes or any uh, high resolution camera, we see that, and it is the evidence of nebula theory. Nebula, the many nebulas are here, is the plural form of nebula. What is? What you think? The plural form of nebula is nebulas? No, the plural form of nebula is nebulae. Okay, so we see Orion Nebula in the sky with naked eye always. Here, telescope is not needed. But in Orion Nebula is the brightest nebula. Okay, so we will see with the naked eye in the sky. In the night sky, I always recommended you. Uh, this diameter of the Orion Nebula is twice of uh, is twice of moon. I didn't remember like that. It's twice of moon, and nebula often nebula often from stars. The star forming regions of nebula, different nebula have different star forming regions names. Like Eagle Nebula, one type of nebula, has the star forming region like names pillars of creation. That's names always uh, given by human. Pillars of creation. Here, the star formations due to adduction process and condensation processes, rapid cooling, and due to the gravitational force, the stars are formed. Okay, and it's think that and the remaining material. It is believed that remaining materials are creates planetary bodies. Now we learn about the types of nebula. Uh, you will be appreciate that the names of nebulas like diffusion nebula, emission nebula, reflection nebula, and others based on is the name is based on is on their behaviors. So you can easily remember there's the types of nebula and their phenomena. So first we learn about diffusion nebula. What is diffusion nebula? Diffusion nebula is that nebula those nebula have not a specific boundary. Okay, or defined boundary, well defined boundary. They are well defined boundary, they haven't. Okay. Now, emission nebula mainly made of ionized hydrogen. Students, let's remember, you learn in class 11, that's the ionized, about the ionized hydrogen, the ion, energy states of hydrogen, the series you learn, that Lyman, Balmer, Paschen, Brackett, Food, Humfest, the states. So when hydrogen have a single electron, you know that the single electron, when it drops from higher energy states to lower energy states, it's emit waves, EM waves. Okay, it emits EM waves, and its EM waves is like an energy wave. So in this way, it emits energy. And in this nebula, we see this phenomena because this nebula is made of ionized hydrogen. Okay, so third one is reflection nebula. Reflection nebula is the nebula, uh, which is those nebula, those nebula which doesn't emit light, but it can reflect light, which is coming from the other star. Okay, dark nebula. Dark nebula is this nebula is not illuminated by stars, and uh, it doesn't uh, emit light. It occurs like a opaque object. No. uh, so it is the dark nebula. And then we know about the planetary nebula. What is planetary nebula? Planetary nebula mainly creates stars, and the at the end stage of stellar evolution. At the end stage of stellar evolution, we see the condensation, the compaction, and for the gravitational force in the star forming region of a nebula, a star forms and forms planetary nebula. Okay, planetary nebula is also have same phenomena, but the time period of planetary nebula and is much greater than planetary nebula. Planetary nebula, it creates stars rapidly. Okay, in the in the case of stellar evolution. Okay, it creates stars rapidly, like time period. One example is as the time period of LAGB phase 2 planetary phase. LAGB phase means late asymptotic, G for giant, B for branch, and that is phase. LAGB phase, late asymptotic giant branch phase to planetary phase. This in the in between time in those phases is very less. So in this very less time, the stars are formed. So this nebulas is called planetary nebulas. And last, the most exciting nebula is supernova nebula. So what is supernova nebula? Supernova nebula is those nebulas, uh, uh, those nebulas which is formed by the exploration of a star in his last stage, in its last stage. um, it's okay, I tell more about this. At the end of the and at the end of life of a star, the stars are, and the gases of the star are uh, going inwards or falling inwards, or it heated up and explode outwards, or or expands outwards or explore outwards is mainly the exploration process and explode, and many pressure waves generated. It is a in that type of exploration we see that's nebula is called supernova nebula, and it is a special type of diffusion nebula. Why? Because a supernova nebula also haven't any defined boundary. Okay, then we learn about the planet formation. Then we learn about the planet formation or solar system, mainly solar system formation. We go to first the theory of collapse. A nebula in the formation, a nebula have internal pressure waves. Okay, you think that it is a cloud of nebula and it have internal pressure waves. Okay, and it's also have gravitational waves, a gravitational force which is inwards the direction, and the pressure waves are outwards the direction. So here we see the tug of war between pressure waves and gravitational field, gravitational force mainly. uh, so when we see this pressure waves are greater than gravitational force, then the oscillation occurs. Here the pressure force is greater than the gravitational force, then the oscillation occurs. As the gravitational force is greater than the pressure in internal pressure, as the gravitational force is greater than the internal pressure, it collapses. It collapses. Okay, it collapses. So I take I draw some pictures by which you learn this very deeply. So we see here is the nebula. Okay, and the pressure, internal pressure waves, that is the internal pressure waves. Okay, and that is the internal pressure waves, that is the sign is outwards. Okay, here and here, here, and gravitational force is inwards direction. So as the pressure waves, this kind of wave is P wave, and this is gravitational force. Gravitational force. Gravitational force. Okay. And it is the pressure waves. As pressure waves is greater than as pressure waves is greater than the gravitational force, then we see oscillations. Okay, this kind of oscillations. this kind of oscillations. So we see oscillations, and as pressure waves decreases, the gravitational force, for the gravitational force, the whole nebula was collapse করে যাবে. Okay, collapse করে যাবে, ছোট হয়ে যাবে, and is collapse. Okay, it's from shorter size or from the previous. Okay. So it's collapses, and the tug of war is for two force opposites direction to each other. A tug of war is generated between two forces. As the initiation of collapse, we see many nebulas. At the initiation, we see many nebulas have oscillation period in their oscillation periods, because pressure waves is greater than the gravitational force. But our sun also in the oscillation period. So when when others in the other area, a supernova explosion is generated. Okay, so a pressure wave, external pressure wave is formed, and those external pressure waves are creates pressure here. Okay, so those external pressure waves create pressure here. So P proportional to P external. Okay, it is P internal. So P proportional to rho. So here density is getting higher. Okay, density higher here. Density is higher, so internal pressure, effective internal pressure is less than previous. Okay, so gravitational force, for the gravitational force, it's collapses. Okay, now we learn, I give you an idea about this collapse. Now we know about the mathematical expression of that. Sorry guys. Now we see Jean's length. What is Jean's length? Okay, Jean's length is lambda j. What is Jean's? Jeans length. What is Jean's length? So Jean's length is nothing but a threshold length of a nebula in a specific temperature and density. The size of a nebula or planet, the size of a planet, a nebula, in nebula. Okay, the threshold size. Any nebula have length greater than the Jean's length in the specific density and temperature, then the nebula should collapse. Okay, or nebula would collapse. And if a nebula have less than Jean's length, have a size less than Jean's length, so then the nebula doesn't collapses. Okay, and we see about the threshold. The expression is equal to root over cs, sorry, here cs by root over g rho. G is gravitational constant, cs is sound speed. Okay, and rho is density of this planet or material. Okay, so here we expressed it in another way. cs, we know that cs is equal to root over gamma p by rho. So here gamma p is nearly equal to p by rho. So gamma is equal to 1.14 in atmosphere. Okay, is nearly equal to 1. So P by rho, so here P V by M, যেহেতু rho is equal to M by V is equal to RT by M, যেহেতু PV equal to RT when N equal to 1 or mole number is equal to 1. R is equal to K into Na. Na is equal to 6.0 to 10 to the power 23 is a number of molecule. ঠিক আছে, number of molecule. M is equal to Na into M, ছোট m. N is the number of molecules. Okay. So here we express it like that: KNAT and M N ছোট m, sorry, small m, and Na and we'll see KT by ছোট m. So here we put it root over KT by small m into 1 by 0. Okay, so KT by 0 m is KT by 0 m. Okay, so gently put this value and equate this. Now a cloud that mass is equal to mj is nearly 4 by 3 pi r cube, rj cube, rgens cube into rho. Rj is equal to half of Jeans length. Okay. Here Jeans length is depends. Here Jeans length is depends on what? On density first and temperature. Temperature and density. In this equation we say temperature and density, and the Jeans length depends. So in first time I say that the threshold length, it depends on the specific temp. It's in the threshold size of a planet. At first I say that the threshold length size of a planet, okay, in specific temperature and density. And now here we generate two masses, m masses, okay, two gas molecule, two gas cloud which have n number of m masses. Okay, so gravitational potential energy E A is equal to minus gmm by L. Here minus generated because in gravitational potential energy we take a particle from infinity to the gravitational field. Okay, we put it in the gravitational field from infinity. So it is the work done by the environment, not by the system. So it is negative. Now threshold, now thermal energy is equal to 3 by 2 RT. We know that is nearly equal to RT. R nearly equal to R equal to KNA. সুতরাং KNAT. Okay, so sorry, is equal to KNAT. Now, so EA by ET is equal to G M by L and GMM by L and N KT. Okay, Gm by L is gravitational potential, it is thermal energy. And now G M is equal to M is nearly equal to rho by L cube, or equal to 4 by 3 pi L cube into rho. So 4 by 3 pi, we eliminate this, and nearly equal to rho L cube. So we put it here, rho L cube, and M M by N, and here we see the M by N. Here M by N is choto m, small m, because N in M is equal to capital M. So M is equal to capital M by N. Okay, so put it here, small m and L K T. Okay, so here got this G L square KT by G rho M. What is it? It is what is it? It is Jeans length by LJ square. Okay, so L square by LJ square, the ratio of two energies A by ET. Now if in case of that, it's if rho increases, Jeans length decreases, because of Lj is proportional to 1 by rho, root over rho. And as T increases, temperature increases, Jeans length increases, because Lj is proportional to root over T. Okay, temperature, T for temperature. So when in the tug of war between gravity force and the internal pressure waves, the gravity wins when L is greater than, the size of the planet is greater than Lj. Okay, then I tell you that here if the planet size is greater than the size of Jeans length in the specific pressure pressure or temperature and density, then it started collapsing. Okay. Now we see in the time travel phenomena of two waves. Okay, in this page here here a nebula mass, nebula mass internal waves, P waves here, and gravity force here. The time period of P waves generates from here and goes to here, the time is ts. And the gravity field or gravity force time to sorry, the direction is opposites. And gravity's time to the periphery to center is the time when gravity waves comes from the periphery to center is tg. Okay, tg is equal to root over L by G, or L cube by Gm, because G is equal to Gm by L square. So here we put it here and we derive here it. And now it's now here it equal to root over 1 by G rho G, because m by L cube is equal to rho. Okay. Okay, that is clear. And ts equal to cs by L. Is the distance is L. If the distance is L from the center to periphery, and cs we know it is a pressure waves. Moves in the at sound speed. We know pressure waves moves at sound speed. Okay, so c is the speed of sound and L is the length or distance that pressure wave covers. Okay, it's nothing but S is equal to Vt formula, where T is equal to S by V. Okay, so T is equal to S by V, and it is I do it wrong. Okay, I write it fresh. L by CS. Okay. So now TS is equal to L, and CS. What is CS? CS is nothing but we generate here. You know that here CS is here, we generate here CS is KT by M. So here I also put this formula, root over KT by root over M. Okay, and this is that. So as we see, the temperature increases, TS decreases, or the time period of the pressure wave decreases, or the pressure wave's speed increases. So as the speed increases, it reaches earlier, and it doesn't it always create obstacle to collapse. So it creates oscillations here. As the density increases, as the density increases, Tg decreases, or gravitational waves speed increases. So the gravitational waves moves very fast, and it collapses. Okay, so as density increases, it collapses. As temperature increases, it oscillated. So in the sun, uh, we see temperature is very high, so it is now in oscillation period, not in collapse period. In the so you say, so how the collapse is creates, because as in the primitive condition, in the primitive time, or in the primitive time in the primitive time kinetic energy and kinetic energy and potential energy converts into heat energy. So temperature is always increased. So how collapse is creates? So it is a cause of supernova. I said you earlier that the super in the other area, a supernova explosion creates. So many energy released, pressure waves are creates. These pressure waves are came across and pressurize the nebula. Gives the external pressure. Okay. So the combination of external pressure and gravitational force, it collapses, because the internal pressure is now less. Okay. As the we see that in the mathematical method, I told you that as the external pressure waves are increased, the density, external pressure waves increase density of the nebula, because p proportional to rho, external pressure waves gives pressurize, and external pressurize it, and increase the density. As density increases, I said you earlier that t of time period of gravitational waves is, the formula is root over 1 by 0. So as rho increases, tg of the time period decreases of gravitational force. So as time period decreases, gravitational waves velocity increases, so collapse happens. So it is a tug of war. Here their gravity wins. Now you conceptualize the graph and have a bigger idea or greater idea, and clear your concept about this nebula. So let's start. So now the graph is it. I draw it roughly, so don't mind. Time scale, here time scale, here size, SIZE or L. Okay, so as time increases, as the time increases, as we see here, the graph here to here. Okay, I explain it. I will explain it. LJ, and it is the TG, it is the TS. So TS is L root M by root KT, and TG is equal to 1 by G rho. Okay, 1 by 0. So here you see that the as in the point P and the point Q. Point P is the length L1. L1 is less than G's length first, and the time period of is TS here, and here হচ্ছে TG. So here TG is greater than TS. So the time period of gravitational force is greater than the time period of the pressure internal pressure waves. So here oscillation occurs. Okay, because the speed of the pressure is greater than the speed of the gravitational force. Okay, but here you see the TG, or the time period of gravitational force, is less than the time period of pressure waves. So the speed of gravitational force is increased. So here you see collapse occurs. Here oscillation occurs at the point Q. Collapse occurs because the length of OQ is equal to L2. L2 is greater than LJ. Oh, sorry, I write is wrong. L1 is greater than LJ, L1 is less than LJ, and L2 is greater than LJ. So here we see, and you clear your concept that the size of the planet, if the size of the planet is less than G's length in the specific pressure and temperature and density, then it will not collapse, it will oscillating. And if it is greater than G's length, then it collapse. So our sun is now in this time period, our sun is now in these regions, so our sun is now oscillating. But when the sun size is increases, the time increases, and sun came to here collapse occurs, and for this collapse black hole is generated. Okay, for this collapse. Now I know that is the this is the some concept is very hard, but you should study about that. Now the first we see the theory of collapse, when collapsation theory, and now the theory of spinning. After collapsation we see the energy transformation, kinetic and potential energy is transformed into heat energy. Then we see the spinning. The spinning of the molecule is mainly depends. The spinning of the molecule mainly depends on conservation of angular momentum. Okay. Okay, students, mainly you learn that this whole theory of origin of Earth or nebula concept is situated into two fundamental physics law. Is based on two fundamental physics law. First is conservation of angular momentum, and second is the theory of gravitation. Okay. The theory of gravity, it's mainly depends in two major concepts, rules in physics. In the cases of the spinning nebula, in the case of spinning we learn that I change the page. Okay, change the page. In the spinning method, Angular momentum concept, we know angular momentum m1 v1 r1 is equal to, what is the conservation of angular momentum, m2 v2 r2, or I1 omega 1 is equal to I2 omega 2. Here I is equal to mr square, or and omega is the angular speed. Okay, I is equal to mr square, omega is the angular speed, and it is the other formula. So now for rotation for all material, and here in the center we form stars, okay, and in the other region forms planetesimals. Okay, for the rotations these planetesimals are formed. If rotation has not occurred, then not the structure are not formed. Okay, so it is the prototion, and the remaining materials is called planetesimals. Okay, so first we conceptualize this. Here the sphere, okay, you think it like a sphere. Hey, like a spare parts, and it then flattening for extreme rotation. For extreme rotation it's flattened into it, and that, and here sun and planet, others planet is flattened, because our solar system is flattened system, not a spherical system. Why? For the spin, you know, here it is the center. So in the point P, the gravitational force here, for the gravitational acceleration also in this way, and here the angle is, in this square angle is phi, and the angle is theta. Now it is G, and here for the centrifugal force, the centrifugal acceleration omega square r. So it is theta, and it is phi. So here omega square r sine phi, or omega square r sine theta cos theta. Here omega square r cos phi, or omega square r sine theta. Okay, so the net acceleration here is equal to g minus omega square r, because two are different directions. So omega square r sine phi. So here we see gm by r square omega square r sine phi, and so students, that is the net acceleration. In those cases, if the particle moves towards the center, so phi increased. Okay, phi increased, moves towards the center, phi increased to 90 degree. As the 90 degree is created, then here I put, and the net acceleration at the center you see r square minus omega square r. As the acceleration reaches in the value, as the acceleration reaches the value, then the contraction due to gravitational fields stops, and now the particle moves away from the center, and it creates a sphere to ellipse, and then it's flattened like a disc, like a disc, and creates the prototion and here planetary materials. Okay, so as the acceleration reaches here, then the contraction stops and the particles moves away and flattening is started. So as flattening is started. Okay, and at the last stage is called condensation, and the second last stage is called condensation. The second last stage is called condensation. In the condensation process, the gases are condensed in liquid or solid and from stars and planetary materials. Okay, and due to the advection process, the created planetesimals are planetesimals increases their sizes and increase their sizes, and the advection occurs due to the electrostatic force and gravitation force. Okay, always the gravitation force. So now I starts about the advection process. Advection process, prototion is creates, then in the, near the sun we see helium and hydrogen gases, and as we and dust or rocky particles. As we go away from this protosun, we see ice dust. And here, due to advection process, planetesimals appear, rocky planetesimals, and here icy planetesimals. Okay, rocky planetesimals, icy planetesimals occurs. And now advection process due to here rocky planets three types. Okay, rocky planets or terrestrial planets. Rocky planet is called terrestrial planet, which is nearer to the sun or star, and which is away from the which is far away from the sun is Jovian planet, which is made of gases, and its size is much higher than terrestrial planets. Okay, this is Jovian planets like Jupiter is a great example. And at last we see the ice planets made of ice dust. Okay, so rocky planets or terrestrial planets, Jovian planet or gassy planets, and then the ice planets. Jovian planets, as we go far from the sun, the planet's size increases in the in the increases. We see in the Jovian. We always see in the Jovian planets, the size of the Jovian planets is always greater than the terrestrial planets. Okay, it is the process of actions. And now we came to the interesting process, the earth forming process. Okay, earth formation process. As students, let's see earth formation process. Earth formation is 30 million years to form earth. It takes 30 million years to form earth. 4.56 GA to 5.49 GA. Okay, as here MR is equal to mean earth radius. Okay, mean earth radius is nearly equal to 6371 km. Okay, 6371 km. Let's see 0.1 MRE here, 0.2 MRE, 0.3 MRE is important because it is the size of moon size, and 0.4 MRE here fast atmosphere is formed, and 0.4 MRE fast atmosphere is formed. As 0.5 MRE the ocean, formation of magma ocean. What is it is magma ocean. It is the magma ocean. Okay, and it is the mantle core. It is made of nearly this made of silicates and metals. Okay, and this is the mantle ocean. In 0.5 MRE, mantle oceans are formed. MRE. Okay, now the action is generates, and 0.7 MRE formation of core. It is core formation of core. At 0.9 MRE formation of outer core and inner core, and for 0.1 MRE, and it is giant impacts, consolidation, magma oceans, consolidation is magma oceans. Now at the beginning, any planetary body or planetesimals is homogeneous, but due to the erection, homogeneous mainly made of metals and silicates. Due to the erection processes, the size of the planet is bigger. The still planet is bigger, and the composition is heterogeneous now. And many people thinks that Earth's ocean or water is created from the atmosphere, but it's not. Earth's ocean is created from the core or mantle. Many fusion reactions where H2O is generated or releases. H2O is releases mainly, okay, or generated, and those H2O creates ocean. At the last stage of Earth formation, we see lithosphere. The lithosphere was formed. Okay, the last stage of Earth formation. So here I stops, and I think you would enjoy this class because it is very interesting. It is very interesting to you, the how the earth formed, how the nebula from the nebula, from solar nebula the solar system forms, and earth, then earth forms. It is very interesting process. You should learn this. Okay, I try to my best to teach you this uh, fundamental processes. Uh, you should know more about in the in many astronomical or astrophysics books, like or many planetary geology books. Okay, tata.